Alright, so in this video we are going to look at the application of arc length. The application of arc length. Now we know that the arc length is given by r times theta. The r times theta. Alright, so let's look at, we have discussed on it already, so we need not to talk much about it. Let's move to our first question about the application. A rope, and I hope you all know a rope. A rope is being wound. Wound. Hope you can see what I'm doing. Alright. It's wound around. No, there should be. It's being wound around a drum with radius 0.8725 feet. How much rope will be wound around if the drum is rotated through an angle of 39.72 degrees? Alright, so that is the application. Now you have to know that the length of rope wound around the drum is the arc length for a circle of radius. That is the radius 0.8725 feet. And a central angle of 39.72. So to start with this, we need to start by recognizing our formula for the arc length, and that is the arc length is equal to the radius times theta, that is the angle. Very good. Now, what we need to do is that you have to know that the angle here is given to us, this is the radius. Now the angle here is given to us in degrees. It's given to us in degrees. So we need to convert it to radians. Alright? So we know that if this is degrees and we are converting to radians, we need to multiply this by pi over 180. Then the results, anything that we get inside here, we multiply by 8. So by substitution, we know that the radius is 0.8725. Then we multiply by the angle, which is 39.72 times pi over 180. Pi over 180. Alright. So when we multiply this by this, then we end up getting 0.6049 feet. 0.6049 feet. So that is that for the first question. Alright. Let's look at the second question. Okay, question 2. Two gears are adjusted so that the smaller gear drives the larger one. So that means that there is a smaller gear and a larger gear. Alright. If the smaller gear rotates through 225 degrees, through how many degrees? Listen well. Through how many degrees will the larger gear rotate? I read again. Two gears are adjusted so that the smaller gear drives the larger gear. If the smaller gear rotates through 225 degrees, through how many degrees will the larger gear rotate? A very nice question to look at. Now, first of all, we need to first find the radian measure of the angle. And you know the red formula for the radian measure of the angle, that is going to be theta times the radius. So we need to first go and find the radian measure of the angle. Secondly, we will find the arc length. We will find the arc length. Sorry, the radian measure of the angle is coming from the what? From the arc length. Alright. This is the arc length. So the radian measure of the angle will be, now we have the degrees. This is the degrees. So we have to convert it to what? The radian. That is the first part of saying the radian measure of the angle. I don't mean this. This is the arc length rather. Alright. Thanks for your understanding. So we need to find the arc length on the smaller GA. That determines the motion of the larger GA. Because we are saying that two GAs are adjacent so that the smaller GA drives the larger GA. So this means that it's the smaller GA that determines the motion of the larger GA. Very good. So now let's start with the first one. To convert, so since we are converting to radian measure, alright? So since we have 225 in degrees, to convert it, we just multiply 225 by 5 over 180. And that is going to give us 5 pi over 4 radian. 5 pi over 4 radians. So this is for the smaller GA. So for the smaller GA, the radian measure is going to be 5 pi over 4. Very good. Then we move on to the second stage or case where we are going to find the radian measure. So the radian measure, the arc length is going to be r times theta, right? So we know that from the question, what is it? Sorry, I'm coming. Oh, the radian here, the radian measure here is 2.5. Let me add it to the question. Where the R is 2.5. So the R given here is 2.5. Alright, so here we get 2.5 times the 5 pi on 4. The 5 pi on 4. And that is going to give us 12.5 over 4 pi, which is the same as 25 pi over 8 over 8. Alright, 25 pi over 8. So now an arc with this length on the larger GA corresponds to an angle measure in radian where so this is for the smaller one. Alright, so when x equals to r theta, so we move on to convert that. So we know that 25 pi over 8 is going to give us 4.80. Alright, so that is 4.8 theta. So now there is 2 radians here. It's supposed to appear in the question. Alright. This is for the smaller. This is for the smaller and that is for the larger. So what I mean is that this is for the smaller GN, for the smaller GN. And for the larger GN, it's supposed to be appearing in the question. But I made a mistake. So for the larger GN, the larger GN is going to be 4.8. 4.8. So you can see that the radius for the smaller GN is going to be the same as the radius for the larger GN. Alright. So we use the smaller GN and the radial measure for the smaller GN to calculate the arc length. So for the smaller GN, so this calculation is for the smaller GN. Therefore, this arc length that we have here is the smaller GN. Alright. And note that in the question, the angle given us that we have converted to radian is the smaller GN. But the question is asking, through how many GN will the larger GN rotate? So we are looking for the angle for the larger GN. So when you come to here for the larger GN, that is what we're looking for it right now. Alright. So we are going to find theta. We are going to find theta. Okay. So for the larger GN, I'm coming. Let me name here S1, here S2. Alright. So for the larger GN, it's going to be S2 to be equal to 4.8. We know that for the larger GN, the radius is 4.8. But we don't know this, so it's times theta, which is 4.8 theta. So we don't know that. Let's leave that. And this one for the smaller GN, the arc length is 25 pi over 8. For that one is known because the radius and the theta is known. Alright. So S2, for that one we don't know the angle, that's why we are doing it like that. So for us to get for the angle for the larger G or the degree for the larger G, we need to equate S1 to what? S2. We need to equate the S1 to S2. So let's go and find that. So we know that S1 is equal to S2. This is 25 pi over 8, which is equal to 4.8 pi. So to get 4.8 theta, so to get theta, I don't have a calculator, that's why. Okay. So like when you do the same as over 1, so when you do cross multiplication, I'm going to get 25 over 192 pi. So we are going to get theta to be equal to. So we are going to get theta to be equal to. Okay, so let's leave it at 125 over 192. So this is the radian measure for the angle for the larger GN. Alright, so converting theta back to degree, because here for the smaller GN it was given to us in what? Degree. So let's go and convert that one to degree. So to do that, then in degree, we just multiply 125 pi over 192 times 180 over pi, and that is going to give us 117 degrees. Very good. So we are saying that when two gears are adjusted so that the smaller gear drives the larger gear. So the angle that the smaller gear will be driving the larger gear, the angle that the angle for the smaller gear is given to us to be 225. So for the larger gear, we have to find through how, we are going to say through how many gears will the larger gear rotate. So the larger gear is going to rotate 117 degrees. So that is going to be your conclusion for that. We will be looking at the third question. Alright, so we have our third question on the board, and this is similar to the second one that we just saw. Okay, this question says that a belt, this question is one of our lecturers' exams. A belt connected a pulley of 3-inch radius with a pulley of 7-inch radius. See, with this, I have bring everything alright, unlike the second question that I omitted some parts. So a belt connected a pulley of 3-inch radius with a pulley of 7-inch radius. If the larger pulley turns through 24 radius, if the larger pulley turns through 24 radius, through how many radius will the smaller pulley turn? In fact, the first day I encountered this question, I was thinking of using ratio and proportion. Please don't use ratio and proportion here. If not, you'll get it wrong. So, what you should know is that since the belt connecting the two pulleys doesn't shrink or stretch, the distance a point move on the circumference of the smaller pulley is going to be equal to the distance a point move on the circumference of the bigger pulley or the larger pulley. So that is why we are here. We need to go and equate the arc length for the smaller pulley to the larger pulley. Alright. The reason is that for distance for the same, since this one it can't shrink or stretch, we can equate the two. Very good. So we know that S1 is going to be equal to S2, similar to the one that we previously solved. But that one is about a gear, but it is a pulley, still the same thing. So we know that where the arc length is the radius times theta. Very good. So now the arc covered by the pulley, the arc covered by the pulley, is going to be S1, which is going to be 7 times 24. Alright? Because here, I think that a belt connected a pulley of 3 inches radius with a pulley of 7 inches radius. If the larger pulley turns through 24 radius, so the larger pulley, now watch, the larger pulley goes with the larger radius, and the smaller pulley goes with what? The smaller what? Radius. Therefore, to find the arc covered by the, make it clear, are covered by the larger pulley. The larger pulley. We need to multiply the larger radius by its angle. Now, let's look at the angle given. We know the radius for the smaller pulley, the radius for the larger pulley. But let's come to this side. If the larger pulley turns through 24 radius, how we can see that? So the larger pulley, the radius is given to us to be what? The angle is given to us to be what? 24 radian. The thing is radian, not radius. Where is it? 24 radians, not radius, sorry. 24 radians. 24 radians. Through how many radians? Through how many radians? Alright. Through how many radians will the smaller pulley turn? So, for the larger pulley, the radius is known, and the angle, which is in radians, is also known. Radians, not radius. And for the smaller pulley, the radius is known, but its radius is unknown. Alright? So, that doesn't mean you can use the idea of ratio and proportion. In fact, you get it wrong. You make that. So, they are covered by the pulley. The arc covered by the larger pulley. Let me play this. By the larger pulley, which is S1. So S1 is going to be theta times what? The radius. And that is 24 times. Here, don't convert the radians to degree, leave it as such. So times 7. And that is going to be 168. And the unit, you have to bring a unit. It's going to be inch radians. Alright. Now let's go for the arc. Covered by the smaller pulley. And that's going to be S2. But with that one, you know that it's going to be theta times R. Now, the theta is unknown, but the radius is known, and that is 3. So here we get 3 theta. For us to get the radians for the smaller pulley, we equate S1 to S2. And I have already explained that it is because the two pulleys doesn't strain or stretch. The distance a point move on the circumference of the smaller pulley is equal to the distance a point move on the circumference of the bigger pulley. It's the same idea that we use even if you are talking of the gears. Alright, so here is going to be 168 is equal to 3 theta. So 3 theta is equal to 168. Divide both sides by 3. So theta will be equal to, I think, 56. 56. So 56 what? 56 radians. So you conclude, hence, 56 radians is the smaller pulley turned through angle of 56. 56 radians is the smaller pulley turns through the angle, through the radius of 3 inches. Through the radius of 3 inches. So that is the end of the application. I would like to encourage you to continue solving more questions. And that is all. See you for the next video.